Welcome to the Hazard Identification and Mitigation Coaching module. Today, we will be discussing how to identify hazards and the mitigations we can use to stay safe. Before beginning work, we're going to perform a hazard identification. To do this, you're going to ask yourself three simple questions. What am I about to do? How could I or someone else get hurt? What can I do to prevent myself or someone else from getting hurt? Asking and answering these three simple questions can put yourself in a great position to be working safe. The hazard wheel is a tool we can use to identify hazardous energy that may cause us harm. Electrical energy is a major hazard in workplaces and includes power from electrical systems, circuits, and equipment. Exposure to live wires or improper lockout-tagout procedures can lead to electric shock or electrocution. Gravitational energy refers to the potential energy stored in elevated objects, tools, or even people. If heavy objects are not properly secured or supported, gravitational energy can lead to falls or collapses. Motion or kinetic energy is the energy possessed by moving objects. Moving machinery or parts can cause injuries if they are unexpectedly activated. They can also include moving vehicles and equipment. Mechanical energy is generated by moving parts of machinery such as rotating shafts, gears, belts, and hydraulic systems. Mechanical energy can cause crushing injuries, cuts, amputations if machines are not properly guarded or accounted for. Pressure systems such as hydraulic or compressed gas can cause a sudden release of energy, causing flying objects and fluids. Radiation energy involves the emission of energy in the form of waves or particles from sources like ionizing radiation, X-rays, gamma rays, and non-ionizing radiation such as ultraviolet, infrared, microwave. Sound energy involves exposure to high levels of noise from various sources, including machinery, equipment, and tools. Prolonged exposure to excessive noise levels can lead to hearing loss, tinnitus, and other auditory problems. Temperature refers to the energy present in hot surfaces, steam, or hot liquids. Contact with hot surfaces or substances can cause burns or scalds if proper precautions are not taken during activities. It can also include hot and cold weather conditions. Biological hazards in the workplace encompass exposure to living organisms or their byproducts that can pose health risks to workers. These hazards can include bacteria, viruses, fungi, parasites, and toxins. Chemical energy is present in substances that can react or release energy during certain conditions, such as chemical reactions or combustion. Improper handling or accidental exposure to hazardous chemicals can result in fires, explosion, or toxic exposures. The hierarchy of controls is a system used to manage and reduce risks in various situations to ensure safety. It provides a structured approach to selecting and implementing measures that prevent or minimize hazards. The hierarchy consists of 5 levels, listed from the most effective to the least effective. It starts with the most effective of elimination of the hazard, then substitution, engineering controls, administrative controls, and last, personal protective equipment. PPE is always your last line of defense after the other 4 methods have been tried and implemented. Today we'll be working through a usual scenario. The question starts with, what am I about to do? We will be chain lining material. Next, ask yourself, how could I or someone else get hurt? In this example, we will be examining how someone could be struck by a falling object and the mitigations we can perform. Elimination is the highest and most effective level. It involves completely removing the hazard or danger from the situation. If there is no hazard, there is no risk. Asking yourself, how can I eliminate the hazard outright, is always the best start. In our scenario, we could potentially use a freight elevator to remove the risk of chain lining material altogether. Substitution. If elimination isn't feasible, the next best approach is to substitute the hazardous element with something less risky. This involves replacing the dangerous material, process, or equipment with safer alternatives. Ask yourself, can I change something to make it less hazardous? In this scenario, if a freight elevator was not available, we could substitute the chain line for a hoist, making it less hazardous. Engineering control. This level involves designing the work environment or process to minimize the hazard's impact. It includes creating hard barriers to separate us from the hazard. In this scenario, if elimination or substitution wasn't available, we could use an engineering control of overhead protection to help keep us safe. Administrative controls. These are rules, regulations, and guidelines put in place to manage the hazard. This level relies on changing the way people work or interact with the hazard. It could involve implementing specific work procedures, providing training, and setting up warning signs. Ask yourself, are there procedures or policies that I can use to reduce my hazard? An example in our scenario would be to use verbal and twist communication when passing material up. Staggering the chain line to stay out of the line of fire. And stepping back after passing material to stay out of the line of fire. These all rely on the way people work in order to stay safe. And last, we have personal protection equipment. When all other methods are insufficient, PPE becomes the last line of defense. Ask yourself, what can I wear to further protect myself from a hazard? This can include eye protection, impact-resistant boots, hard hats, impact-resistant gloves, and tethering tools. To review, anytime we encounter a hazard, we want to examine the hierarchy of controls, starting with the most effective elimination, followed by substitution, engineering controls, administrative controls, and always last, PPE.